Good afternoon and thanks for joining this webinar. We can now start with the presentation. Today we are focusing on the EOSC-hub technical architecture for the European Open Science Cloud. And our speaker will be Giacinto Donvito from the National Institute for Nuclear Physics in Bari, Italy. And myself, I will be introducing the EOSC-hub project very briefly. I'm Francesca Spagnoli and I'm working from Trust IT Services private companies. We are also based in Italy, Pisa. So thanks again for joining this meeting. I think we can start with the presentation. Next slide, please. This webinar will be recorded, of course, and will be published online. You can access both the slides and the recording of the webinar on our EOSC-hub webinars page. You can find the link here under webinar program. And we would like also to have it as an interactive webinar. So please feel free to ask your question at the end of the presentation from the speakers. And you will be, we will be having the possibility to raise your hands and to ask some questions or either add them on the chat. We will take them by order and our speaker will get back to you as soon as possible. If you have any other question at the end of the presentation, you have the contact of Giacinto Donvito and you can also send him some emails. Next slide, please. I will be now introducing very briefly what EOSC-hub is about. I'm sure you're very familiar with this topic, but just to provide you some general information and also to focus a bit on what are the topics for today's presentation. Next slide, please. EOSC-hub is delivering the integration and management system of the European Open Science Cloud in order to act as a European level entry point for all our stakeholders. As perhaps you know, it's a very huge project with 20 digital research infrastructure, for example, including EGI, UDAT, and Indigo Data Cloud, all with the purpose of offering altogether services, software, and data for advanced data-driven research and innovation. We have more than 100 partners from 53 countries and very huge staff involved. The coordinator is Stichting EGI. The project is about to going into its conclusion in December 2020, but will be further extended until March 2021. So a few more months left. Next slide, please. What are our main activity areas? Basically, the hub is focused on 4 activities, services, which includes both baseline services such as storage, computing, resources, applications and tools, but as well as data and trainings and consultancy services on business exploitation plans, for example. Then we have federation services, which includes the EOSC portal and marketplace, the authentication authorization service, the accounting monitoring, and one help desk to support newcomers to understand how to integrate their services into the EOSC-hub. Then we have a set of federated operations, which can summarize, for example, in customer relationship management, lightweight certification of providers, and SLA negotiations. And finally, the process and policies, the terms of use, the compliance with the fair data principles, and the security regulations and standards. Next slide, please. Today, we will exploit some key results that EOSC-hub has developed during these years. There are quite a lot, as you can see from this image, and the technical architecture of EOSC-hub is mainly focusing on most of them. It's important to focus on the EOSC service portfolio, the portal and the marketplace, as well as the service management system and the integration guidelines that are included in these services, such as the hub portfolio, developing different key exploitable results. But as you can see from the picture, we have several other actions and activities that you can access as a service into the EOSC-hub platform, and you can already download them or use them for your purposes. Next slide, please. Now, I would like to give the floor to Giacinto Donvito, EOSC-hub Technology Coordinator at the National Institute for Nuclear Physics in Bari, Italy. Please, the floor is yours, Giacinto.
Thank Thank you, Francesca, and thank you for the people joining this webinar. As Francesca already anticipated, I will be very interested to know also your opinion and your comment and question on what we are showing you. As you will see, we will give you some times for this at the end of the presentation, but also feel free to ask a question in chat during the duration of the speech, so that eventually I can also take the opportunity to answer to those comments and questions. My role in the EOSC-hub is basically to chair the technology committee that is coordinating most of the activities you will see in this presentation, and to lead the WP10, that is the technology work package. Next slide, please. Okay, so basically what we are showing you is our proposal for the EOSC technical architecture. Next slide. Obviously, this does not comes from out of the blue. There are some activities already going on in this, some from the initial part, the initial period of EOSC project, but also before that period. For example, with the past project like EOSC pilot project. So next slide. Just a very quick overview of what was already achieved before EOSC-hub started. There is another project called EOSC pilot that already started working on service architecture. So obviously we were aware of this effort, and we tried to also take into account all the activities and documents produced by during this effort, and trying to go further, starting from what already achieved. Basically, they were already evaluating all the services available and how they interact among themselves, trying to recognize different classes of services and different categories. The categories are here well listed: front-end services, security and trust, open science, data management and data analytics, then EOSC governance and management, and then the compute and cloud platform. Next slide, please. Here there is a very draft overview of how the 47 services are split among the 5 categories. I will not go into any details about that because this is not effort from EOSC-hub, but if you are really interested in this, there is a link in the slides that you can follow and achieve the service architecture that was released by EOSC pilot. Next slide, please. Starting from what is already available, we provided the very first draft of technical architecture version 1. The deliverable was 10.3. Also, this is public available in the EOSC-hub website. You can grab it from the official website. Basically, what we tried to cover was the details on different service type, with the definition of which are their functions, which relationship there could between, among all the components, and the relationship of those services towards the end users. But also the original idea was starting to understand how those services could be composed together, how they could interact together, with the ideas of putting this composition of the services into the hands of the developers that could use this approach to build new services. Also, with the idea of onboarding new services into the EOSC catalog, because obviously this should not be understood as a closed environment, and then how to offer those services into the app so that user could consume those. One particular point that we were from the beginning really focusing on is the possibility to provide guidelines for the standard and the protocols that are adopted or could be adopted depending on the cases for each of the technical areas. This, in our opinion, is the key for interoperability. So starting from open standard and widely adopted protocols, you can be sure that the services can be interoperable among themselves. Next slide. This was the old vision of how we categorize the services into the first version of this service technical architecture. Sorry. And if you see here, you have different category of services. The federation services, where AI, operation, accounting, monitoring belongs to, that are needed in order to make
all the representation of the services give you an idea of how the services could be categorized. So the common services obviously rely on, I was telling that the common services obviously rely on compute and storage facilities, but they were consumed via those common services that are used also by the end user directly or via the implementation of specific community services that we call thematic services. And obviously all the details about this initial categorization of the services you will find in the deliverable 10.3 that is available in the link you will see in the slides. Next slide, please. Okay, what about the service composability and interoperability guidelines? I mean, one of the key points of EOSC-hub is really working on this, on providing the way the services could be integrated and how they could be used in a composable framework. The idea is that by means of this approach, not only we can easy the exploitation of the services, but we can also easy the life of the developers that are using EOSC services in order to implement their own community services. And this means that their activities is faster. I mean, they need less time and less IT skills in order to provide the community service. The idea, this also gives the possibility to the end users to rely on well standardized protocols. And for example, it's easier, just to make some concrete example, it's easier for the end users to rely on their own OMA credential for the AI, for example, because we all exploit the same AI protocol and standards. And that's the way we somehow give the guidelines for the AI in terms of common protocols and widely distributed standards. The idea is to describe APIs and standards that each of the services are using in order to, help the developers to develop those services, and also to use examples already done by communities to try to enlarge this use cases and to enlarge this knowledge to the other community that still don't have that experience. Next slide. Going a bit deeper into the services that we are talking about in the next slide. Okay. How this is working from the practical terms. So if you go, this is an animation. If you go in the next, okay, from the very top of the stack, the end users see the thematic services that are community specific service or capabilities that is able to provide to the real end users some facilities or some technology that they need in order to do their work. Soon in the stack, lower in the stack, there are the common services that are more generally available services where you can consume compute, you can exploit storage, data management, data movement, etc. So there are basic functionalities that could be obviously exploited by themselves, but typically they are integrated into more high-level services like the thematic one. Next animation. On the bottom of this stack, there are what we call access enabling services. Those are services that give you the possibility to discover which are the services into the catalog, that give you the possibility to order a service or to enable workflow or to have a common help desk for different communities in order to interact with the service provider, or to have information about the accounting, etc., etc. So this, if you see in a stacked manner, this is the typical approach we propose to our users. Next slide, please. Next, please. Okay, so going further into the service composability, if you go next slide. This is the general approach we try to propose to the developers. So let's assume, for example, that there are thematic services developers. They have the possibility to choose among the services in the hub portfolio, so the federating core services, and from the common services, what are their needs. In the next animation, they pick some of the things they need, both from the hub portfolio. For example, they would exploit the AI services provided from EOSC and put their services at the end into the marketplace. Next animation. And obviously, they can also add capabilities in the fields, for example, of a compute orchestrator or enable a data management part. Altogether, those services could be joined with, more less effort, and build a new thematic services that then is also published into the EOSC marketplace at the end. Next slide, please. These are more concrete examples, just to make a real life example. So there is one thematic services named DODAS that is, for example, joining together the possibility to use CGI check-in with a dynamic approach for data analytics in order to provide computational resources in a very dynamic way, and rely on the EGI-fed cloud computing resources. All those services together are provided like DODAS thematic services to the end users, so that the end users just use the thematic services as it is, with the whole services built together inside the thematic services. Obviously, the very end user don't know that we are deploying the computation on top of EGI-fed cloud resources, or using EGI check-in for the AI solutions, etc. They just use their own home credential from their own IDP and deploy the code they want to run on top of the computing resources. From another viewpoint, for example, we may have a very high-level data hub for the Earth observation data, with other high-level services for running workflow, and another kind of AI solution. So this could be enabled like a already available workflow to the end users, so that they can use the workflow without knowing that there is a joint connection between other services already available into the EOSC. That's the typical way we propose to integrate the services. Next slide, please. Okay, sorry, next slide. Okay. The idea is that obviously we need to propose guidelines for adopting the same standard or the same interfaces. So especially when you are talking into a specific thematic area, for example, for the data management or for the computing facility, if all the provider that are providing computing, for example, uses the same APIs or same protocols, this make the life easier in terms of integrating those services into other high-level services. Obviously, once you have done experience in integrating those services, you need to describe those implementation, and provide those as guidelines for the other developers that has to do similar work. And obviously, um, having this like public available reusable integrated services make the life of the end users, so the real researcher, easier. Next slide. Okay, next slide, please. Okay. We started with a very high level and general definition of what is a reference architecture. Typically, we need to have a common vocabulary that describe the implementation we are trying to have, and we need to really stress the commonalities between the services that we are describing. What we typically do, and I will show you some example in the next slide, is provide a list of functions and a specific description of the interfaces and the APIs that each of the services are providing. And this obviously putting this into the right context, this gives to the end users the possibility to see all the connection between the services and the thematic areas. Obviously, we may use different level of abstraction for describing this reference architecture. I will show you which solutions we have used in the EOSC-hub technical architecture. If you go next slide. What we have done is to try to describe this really at infrastructure level with a very technical description of the building block, describing which are the functions of each building blocks, and then categorize these building blocks with the typical user interfaces or APIs, etc. So obviously also we have done a lot of work in the common vocabulary effort. If you go next slide, please. This is the very high level approach. So what we have described is different areas of services. There are on the bottom, there are the real resources, so data, compute, storage resources. In the middle, there are all the common services that provide basic functionality on top of those physical resources. On the left, you have all the federation tools that, as I was describing, are providing us the minimum functionalities in order to exploit the AI, to monitoring the services, etc. On the right, you see the portals and marketplace that are used from the end users to access those services, to browse those services, to know what services are available, and obviously the EOSC portal in particular. On top of this, obviously, there are the thematic services that are the more close to the community. And then the user typically could go through the thematic services directly or through the portal, asking which are the services available, etc. Next slide, please. Okay, those are the main building blocks we have already identified in a typical EOSC architecture, in our opinion. So we have mostly described in the previous slide, but this is here listed just for reference. The important information is that when we call building blocks, we are not referring to a specific service. We are referring to a category of services that is able to provide similar functionality, similar, I would say, similar functions. And this is described from the technical specification to understand how they are working and what they are providing and how they are internally built. You will see example next slide, please. Next slide. Okay, the reference architecture, as I was saying, is split across these three main categories. So federation and access enabling services, common services, and thematic services. Next slide. Okay. The first activity that we have done in order to provide the first version of the technical architecture is to understand what could be a good starting base for the building blocks that are needed in order to describe an EOSC architecture. Obviously, we had to start from somewhere. So we started with the most used and most relevant services because they are somehow already comprised in use cases that are quietly diffused and used. Obviously, we get in a kind of iterative process where we define building blocks, we define the components of the building blocks, how they are organized, etc. So we go back to the users, trying to understand if it is well done, and reiterate eventually using the feedback coming out from the user community, developers, etc. So this is iterative process that is still going on. Next slide, please. Okay. If I have to provide you some examples of building blocks, I can, for example, mention the AI services is a building blocks. The AI building blocks is made of different APIs, functionalities, protocols, etc. Obviously, each building blocks is describing with very high level approach different concrete services. So we have, AGI check-in, Indigo EM, B2 Access, etc. All of them are described with the AI building blocks. It's not one single service. It's a category of services that are providing similar functionalities. Or for example, the monitoring. We may have different monitoring tools, but the monitoring building blocks is defined as one single building blocks, etc. Next slide, please. Okay, this is the typical description of a building block. There is an introduction where we describe which are the main functions of these building blocks. Then are the high-level service architecture, where we describe the interfaces with the other building blocks. Obviously, this is very general. It's not specific on one single services. Then we describe also which are the standard that we are using. And we describe in a specific session how similar services could be made interoperable with this macro feature. So how this could be exploited or it is already exploited by some use cases. And at the end, we also provide examples of solution implementing these building blocks. Next slide, please. This will be a bit more clear. Okay, so just to make some examples, we have a lot of common services provided by the EOSC, and if you want to build a thematic services, you may pick the function you need, try to make them work together in order to provide a new thematic services. If you go next slide, please. Okay, next slide. Yeah, this is animation. Okay. Those are examples of a building block that is already published. It's out for it was out for comment for public consultation in order to gather feedback from the user community and developers in order to improve the description. There are AI monitoring, accounting, and help desk. They are already available, and obviously we have gathered quite a few comments on the description, and it was improved, and so this is the typical behavior we foresee also for the future. If you look at those pictures that are, I mean, not so big, but just to make you examples, there is the description of how each of the functions, each of the building blocks is composed internally, and which kind of APIs or standard protocols are providing outside the world. Next slide. Okay, this is a more close look, for example, into the EOSC help desk, where you have both implemented both the first and second level support plus the integration with the other EOSC services. So you have here the way you can interact towards these services, and how internal components work in order to achieve the overall functions that the end users is able to exploit. Next slide. Obviously, in the in the last part of the animation, you will see that there are also suggestions on how you can integrate these services with the other services around that could exploit this, or how these services could be integrated into a more wide architecture. Okay, next slide, thanks. Okay, please. Okay, you can achieve much more details on each of the components in each of the implementation already provided in the documents we have listed here. Also, I mean, from the EOSC pilot scientific demonstrator, that was the past project, but mostly obviously from the EOSC-hub project, you will see here the link to the documents that are related to the thematic services and competence center, where the implementation of those integration is already described. So you will see concrete examples on how different services from different building blocks are integrated together in order to provide more high-level thematic services, for example, or more high-level services that are composing the competence center. In the last link, you will see the community requirement database. That is where we store all this user story on how all the users is interacting with the services, how they are exploiting each of the interfaces, etc. Next slide. Okay, these are how we see and how we propose to have the European Open Science Cloud interaction between the different areas of the services. So we have starting from the metadata, so how we define a metadata, or how we can have an automatic deployment of cluster or services on top of cloud computing resources, or how we can describe storage or data in a fair way, etc. So we are proposing several guidelines for description in many areas of interest that could be usable by the end users to try to rely on the services that are already there in order to build their own use cases. Next slide, please. Okay, next slide. Okay, so at the moment we have already provided so far more than 10 technical specification. Um, there is the link in the EOSC-hub web portal. We already have some public consultation and we will have much more in the future. We already had the second technical workshop in May in order to try to propose this approach to a wide community and also to the other initiative, other project, in order to get people on board and to have their feedback and their reaction. This process is still ongoing and will be ongoing until the end of EOSC-hub, I would say. Next slide, please. And those are the reference link where you will find a much more detailed documentation, both starting from the deliverable and with the last snapshot of the technical documentation available in the last link. And this is what we have prepared together with Diego. We are now, available for any comment or question you may still have.
Thanks a lot. Thanks a lot for your presentation, Giacinto. So feel free to add your questions either in the poll chat or in the usual chat, or to raise your hands, and we will take your questions now. Feel free to ask. Any open question about the EOSC-hub architecture? All shy today? Perhaps, Giacinto, we can just say if there are some steps that we are envisioning to have people integrating the architecture, or if we want to just give some information about the usual steps.
We have already a lot of examples of,
Yeah,
can you hear me?
Yes, we can.
Okay. We have already a lot of examples of communities doing this effort, both in context of the thematic services competence center, but also in the early adopter program. Basically, the typical approach is that we starting from the user story, starting from the description of what is the scientific goal to be achieved, and providing the description of the services that the end users already have in place and maybe they want to keep and maybe enlarge in terms of functionality or in terms of adoption of standard, etc. We starting from this description, we try to see which are the services already available in EOSC that could serve in order to better implement the use cases or to provide more advanced functionality or a better scalability or whatever is needed for that particular use cases. This is typical activity that WP10 is doing in terms of technical support to the end users. So what we typically do is acquiring this request from the end users, try to analyze how this could be integrated into the context of the already available services. And all the examples that are linking into the community requirement database link that I have shared in one of the previous slides is exactly reporting all the steps done for each of those community in order to implement scientific services relying on the EOSC already available services. This is very common. There are a lot of different user story that could be used as I mean, knowledge base, I would say, as examples that could be somehow useful for the developers. But obviously, we are, as WP10, we are here also to support practically from the human point of view, interviewing the end users, try to sit with them and understand how those EOSC services could be useful for their particular use cases.
Thanks a lot for the very detailed explanation, Giacinto. We have one question. What is the difference between EOSC-hub architecture and EOSC Enhance? What will be improved with EOSC Enhance?
I guess that for this, Diego Scardacci could be more update.
Hello, everybody. This is Diego. Can you hear me?
Yes. Hi, Diego.
Hi, Francesca. Okay, for this, I think the answer is simple. EOSC Enhance is working on the EOSC portal and on the related tools for the EOSC portal. So they are focusing on a given aspect, and a given, say, important, but a given component of EOSC. The work that Giacinto presented is more generic and is spanning all the different technology areas that are needed to support scientific application within EOSC.
Thanks a lot, Diego.
Welcome.
Any other question for Diego and Giacinto? Feel free to ask. Looks like the presentation was very, very clear. So if there is any other question, I would like to close here the webinar. Thanks a lot for our speakers and for all the attendees who participated and joined during this webinar. The next one will be in 2 weeks' time, so please register on our EOSC-hub webinar platform, and we will meet you soon. Thanks. Bye-bye.
Thank you. Bye-bye.